Hello and welcome to Micro-Air Corporation's very first YouTube video. Today we're going to talk about installing our EasyStart soft starter into this RV rooftop air conditioner. This is a do-it-yourselfer video for those of you out there who aren't too shy about electrical wiring and air conditioners and internal appliance wiring, things of that sort. Just to make a statement up front though, this is not easy, and for any of you out there who aren't sure or a little timid of this, don't ever hesitate to hire a professional to do the installation for you. Alright, special acknowledgement on this video. First off, thank you very much to our friends Margaret and Brenda for allowing us to use their pop-up trailer here for this demonstration. And secondly, we'd also like to acknowledge Jason and Nikki Winds of the YouTube channel Gone with the Winds, because they inspired us to do this video since they already helped us do a similar video on their new boat on a marine air conditioning installation. Alright, so let's move on. I know time is short for everybody here, and here's what I'm going to do for you. In this video, we're going to do a lot of testing and a lot of comparison with some other products and take you step by step. But for those of you who don't want to listen to me talk throughout this entire thing and cut right to the chase, at the bottom of this video in the description box, I'm going to put timestamps as to where the actual wiring takes place, so you don't have to wait around and you can jump ahead and do that. So let's get started. Alright, so here we are on the roof, and we have our Coleman 15,000 BTU rooftop air conditioner here that we're going to install the EasyStart on. So first of all, let's talk about why you need EasyStart. What exactly is it? What does it do for you? EasyStart is a soft starter. It is not a hard start kit, which is one of these right here that we're going to actually test. It's not a start capacitor. It's none of those things. Although it has a start capacitor inside, this is a sophisticated microprocessor control device that slowly ramps the current to the compressor in order to start it. Now, why do you need to do that? Compressors like this one in particular, draws about 11 amps when it's running, but for a very brief instant when it starts, it draws 5 to 6 times that. This compressor has a locked rotor amperage rating of 54 amps. 54 amps, when you're plugged into a solid utility source, may not be a problem. But when you're plugged into a 2,000 watt generator or an inverter running on batteries just like the Winds, you're going to have issues getting the compressor started. It'll run on those sources, but it won't start. So what good is it? EasyStart solves that problem. It eliminates that start surge. It cuts the start surge down by upwards to 70, even upwards to 75%. So, installing the EasyStart will allow you to run this air conditioner on a generator or an inverter source when it otherwise would not have worked. That's why you need EasyStart. Now, the hard start devices. We get emails all the time about this, and people say, hey, I can go buy a hard start for 30 bucks and it's going to do the same thing as the EasyStart. No, my friends, that is not the case. These two devices are very different. This is like your grandmother's flip phone, and this is like your sophisticated smartphone from today. Two very different devices. These hard starts may actually allow a compressor to start under certain circumstances when it otherwise would not have, but they do not reduce the starting current, which is what you need in order to be able to start on those limited sources, a generator or an inverter system. Okay, first off, you need to gain access to the outside of the air conditioner. No need to get at it from the inside, since that's not where the EasyStart is going to get wired. This particular unit had 4 screws on the top here that we've already removed, and just Phillips heads. And once you take those out, the top just pops right off, like so. There's 2 parts to this air conditioner. There's the part that lives in the outdoors, and then there's the part that lives in the indoors. Your electrical connections are behind this panel over here, and this is where you want to install the EasyStart. You do not want to put the EasyStart outside here because it's going to get exposed to very high temperatures and also blowing rain or anything like that while you're driving down the road or while it's running. So this particular unit, the electrical cover is right here, so we'll go ahead and start gaining access to that. Okay, so we're going to remove these screws in order to gain access to what lies behind this panel, which we believe should be electrical wiring, given the danger shock hazard sticker on the cover. And oh, by the way, another disclaimer here, always make sure you do this with power turned off. We're going to turn power on later for testing, but definitely do not open anything up with power on. This is our electrical box, and we do have a wiring diagram here as well, which we're going to use later, so we'll put that there for now. So in here is where you'll want to wire the EasyStart, and it turns out this will also be a convenient place to mount it. So what we're going to do is we'll probably mount it up inside here and screw it against the back wall and do the wiring. Now, this is an air conditioner. You just can't put screws in anywhere. You have to be careful with that. So we're going to go ahead and we're going to remove this shroud completely in order to make sure that what lies behind the wall in here is nothing that is concerning, that we can't have a screw pass through, and make sure we don't damage anything. Okay, so now we have the evaporator cover off, and we can see inside the actual evaporator coil, a styrofoam shroud that is around the blower motor and the blower impeller. And then here's that electric box where we're going to mount the EasyStart. Behind this panel appears to be open space with just some styrofoam. So we're going to be safe to pass a short screw through this sheet metal in order to mount the EasyStart. We have to be careful right here, obviously, if we were to mount it to this panel instead. As you can see, there's copper pipes back there. That's not a good idea to run screws into those, since you can create a leak, of course. Alright, so before we get started with our testing, let's do the work to identify the critical wires and the critical components to this compressor system so that we can actually do the EasyStart installation. If you look at the wiring diagram, and to many of you, I realize this may look very complicated, you can use it to identify some critical things like wire colors. Obviously, this device is the compressor, and it has a white, a black, and what appears to be a faded red wire attached to it. You can see that it's red based on the color on the inside. If you look at the wiring diagram, over here on the right side is where the compressor is shown. And you can see that the black, the red, and the white are leading to it. There are 3 winding connections on every single phase compressor. The common connection, the run connection, and the start connection. Those are going to become important because those are actually 3 of the 4 wires that you need to find in order to connect the EasyStart. Last wire connection we'll talk about in a little bit. So we've already found, based on the wiring diagram, that this black wire is the common, white is run, red is start. Inside the electric box, behind this bird's nest of wires, you're going to see 3 capacitors. Every air conditioner is a bit different, but you're going to see something that looks like this. First off, the capacitor, the largest capacitor that's over here on the left is the one we're most interested in, and that's the compressor's run capacitor. How do I know that? Well, it is the largest one, and it is metallic. They're not always metallic metal cans, but most of the time they are. And the reason that's important is its neighbor right here, the smaller black capacitor in what appears to be a black plastic can, that's the compressor's start cap. Not all compressor systems have start capacitors. This particular one does. So we're going to leave it installed for our before test to see how well it helps. And then lastly, in this back corner, you will see the fan's run capacitor. Alright, we have a couple of devices here that we're going to use to measure the current that flows into the compressor. And some of these you may recognize. This is what is typically called a clamp-on current probe. The reason they say that is because it clamps onto the wire, just like that. Now, this particular clamp-on probe is pretty good, and it does have a feature that allows you to capture a maximum or a minimum reading. So we can set it up to capture a snapshot, and then it'll also give you the real-time reading. The trouble with these probes that ends up causing a little bit of a misleading issue is that they're not fast enough to capture that surge that occurs when this compressor goes ahead and starts. The surge usually is over and done with in about 1/10 of a second, 100 milliseconds. These clamp-on probes, unfortunately, will average about a half second's worth of data. So when they report the peak, it does tend to be reduced because it's spread out over time. So they're not going to really tell you the truth. So, in order to get a little bit more scientific here, we actually developed our own little homemade clamp-on current probe at Micro-Air, made out of one of our marine control thermostats that some of you may recognize. And we just did some reprogramming in order for it to measure this current transducer device that's on the top, and we put it inside of a Radio Shack enclosure. Go figure. Anyway, this particular device is going to also report the peak current. So what we're going to do is we're going to install it on this wire alongside the other current device in order to get a reading of the peak current that happens when the compressor starts. Okay, we're set up here with our 2 amp probes on the compressor common. And this is going to be our before test to see what sort of peak current the compressor draws when it starts. So we're going to go ahead now and plug in the compressor, and it's going to start right away. Alright, so as you can see, we'll shut her down. As you can see, and hopefully we'll zoom it in here a little bit, get some better readings. The amp probe on the left showed a peak current of 41.1 amps. That's actually pretty good. And then the amp probe on the right showed 21.8. That's because, as I explained earlier, these amp probes do not show you the instantaneous peak. That's why this particular device was brought along, in order to give you the truth. Now 41.1 amps is actually pretty good, given that this particular compressor has a locked rotor of 54. That benefit is actually coming from the start capacitor that the manufacturer installed in this device. However, if you're running on a 2000 watt inverter with a maximum steady state current of 16 or 17 amps, that momentary peak is going to bog down that generator or inverter so much that the compressor will never start and it'll end up stalling, and that's not what you want. So now what we're going to do is we're going to move on to the next test, where we're going to evaluate those hard starts that we talked about earlier in the video. Here. Okay, what we're going to work on now is installing the hard start device, which we have right here. And got the camera zoomed in so that you can see what we're going to do, and we added some lighting onto the whole thing here. Here's the hard start device. zoom out a tiny bit here first so you can see our whole picture here. Now, inside the electric box, we have three components, as we talked about earlier. This is the run cap, this is the start capacitor, both are for the compressor, and this is the run capacitor for the fan. Now, according to the instructions for this hard start, you can see that all it says is wire the hard start device across the compressor's run capacitor. Now, you want to do that without any manufacturer start capacitors that are installed. Obviously, this device is meant to do what this device does. So we're basically just going to swap one for the other. Also, while we're at it here, the start capacitor is not only unnecessary, or you don't want it installed when you're using the hard start, you do not want the start capacitor installed when you're using the EasyStart. So we're going to go ahead and take that out right now. So, first off, one of the wires that leads to the start capacitor will always come from the side of the one side of the run capacitor and basically bridge across to the other side of the run capacitor. All you have to do in order to remove the start capacitor is take off these two wires. And one safety point, run capacitors can sometimes hold charge after they've been energized. More often the start capacitor can hold the charge. So really what we should be doing, what I should have done, is shorted this out before we got started, and also shorted this out. But we're fine, power's off, and it's been off for a while, so the voltages have already bled down. We'll go ahead and remove the other wire that holds on the other lead for the start capacitor. So as you can see here, the start capacitor is completely disconnected. We've disturbed no other connections in here. Now, our hard start. We're going to go ahead, it has two wires. And these two wires need to be installed across the run capacitor. So we're going to put one on one side and one on the other side. Okay, we're ready to conduct the test with the hard start installed. So we'll get our meter set up to capture the max currents, and hopefully everything is visible here. And we're ready to go. Hard start is installed over here, and now we're going to go ahead and apply power and see what happens. Look at that. With the hard start installed, the peak current actually got a little bit worse. 42.1 amps was captured on this meter, which is the more accurate meter, and actually 27.49 amps on the commercial clamp-on. So, we have just proven that the hard starts do not reduce the starting current. They do provide increased compressor starting torque, but they'll do that at the expense of current. That's not what you need when you're trying to start this air conditioner on a limited power source like an inverter, a generator, or a long shore cord at the end of a dilapidated dock. Alright, now we're going to talk about what we need in order to install the EasyStart. There's only 4 wires on the EasyStart, and as you can see on the cover, there is a convenient wiring diagram. And the wiring diagram shows 4 connections where they actually go with the compressor and the run cap. It's very easy. The white wire from the EasyStart connects to the same side of the run cap that goes to your L2 or neutral connection for your incoming power. The orange wire from the EasyStart goes to the other side of the run cap that ultimately ends up going off to the start winding. The black wire from the EasyStart goes to the same signal that ultimately connects to the common of the compressor and this is typically the wire that is switched on and off by a contactor or a relay or a solid state switching device somewhere inside the electronics for the air conditioner. And then last but not least, the brown wire needs to connect to the run winding of the compressor. Now normally, if you examine the wiring diagram from the air conditioner, the run winding connects to the compressor via the white wire, and that actually connects to one side of the run cap already, coming from which connects with a yellow wire from a connector that actually ultimately leads to the L2 connection. So normally the run winding connects to the side of the run cap that corresponds to your L2 or neutral power connection. We're going to disconnect that white wire and we're going to splice it to the brown wire coming out of the EasyStart in order to accomplish this connection right here. So in order to do this, we're going to need some crimp-on terminals, as you can see over here next to the EasyStart. And I've already selected the ones that I'm going to end up using. For the two connections that are end up across the run cap, we're going to use quick disconnect terminals, a blue one for the 14 gauge wire and then a yellow one for the 12 gauge wire, the white and the orange correspondingly. Then in order to make the splice connection between the brown wire and the white wire leading to the run winding on the compressor, we're going to use a yellow 10 to 12 gauge butt splice. And then last but not least, because the more difficult one is going to be the compressor common connection, as it turns out, the compressor common connection is right here. The black wire that ultimately leads out of the box here and to the compressor through our amp probes over there is spliced to this purple wire, which actually leads from the controller, which turns on and off the compressor here. So what we're going to do is we're going to remove this, what's called an end splice, and we're going to add the black wire from the EasyStart to that and crimp them all together with another slightly larger end splice. And that'll do it. And then last but not least, we are also going to have to secure the EasyStart. We've got some sheet metal screws here picked out already with lock washer that we're going to pre-drill into the side panel inside the electric box in order to secure the EasyStart in there, make sure it doesn't bounce around while you're driving down the road and while the air conditioner is running. Wiring in the EasyStart is really quite straightforward. It involves cutting and stripping each of the 4 wires in the harness and crimping on the appropriate terminal that we've already selected. First, to the orange wire, crimp one of the 2 female disconnect terminals. Second, to the white wire, crimp the other female quick disconnect terminal. And if the terminal is of a double crimp type with a strain relief, go ahead and do that second crimp as well. And when you're done, always make sure to check your crimps with a quick pull test. To the brown wire, crimp one side of the yellow butt splice, making sure it is secure. The other side will connect to the wire that leads to the run winding. And then lastly, the black wire, strip that a little bit longer if you're using an end splice, since you're going to twist together the 3 wires before you install the end splice on top of all 3. When using an end splice, make sure the crimp is secure. Doesn't hurt to do a couple extra crimps, and then when you're done, individually pull on the 3 conductors and make sure that none of them come out. Also look for any stray wire strands. And adding a few wraps of electrical tape to an end splice is always good practice to add strain relief and keep out any moisture. So one connection is done. The second connection will be the run winding white wire spliced to the brown wire coming from the EasyStart. In this particular case, the white wire was 16 gauge, which really isn't appropriate for crimping into a yellow butt splice, which is meant for 10 to 12 gauge. So stripping the wire, the smaller wire, extra long and folding it over on itself before crimping into the butt splice will ensure that the crimp is secure. 2 connections are now completed, and for the last 2 connections, which will both be across the run cap, identify the terminals appropriately. The white wire from the EasyStart goes to the L2 or neutral side of the run cap, which in this case had a yellow wire on it. And then the orange wire will go to the start winding side of the run cap. In this case, it had a red wire on it. When you're done, double check all of your connections and make sure they are secure. The installation of the EasyStart is completed, as you've just seen. It's very quick. And now what we're going to do is we're going to do our testing and see how well the EasyStart does and how much it reduces the start current. Now, one important thing about EasyStart that we haven't talked about yet is it's smart. It actually learns your compressor. So the first 5 starts that the EasyStart does, which preferably should always be done with utility power, the EasyStart is actually going to learn what your compressor requires in order for it to start. So the very first start, the EasyStart isn't going to have attained its absolute minimum starting current yet. It's probably going to knock it down about 50%. And then it'll go from there, approaching its maximum reduction in the 70% range. So let's go ahead and do this first start and see if everything works. Here we go. There's a 5-second delay once power is applied, and then EasyStart will begin the ramp. Wham! There's our first start. 23.2 amps, down from 41 amps and change. So as you can see, the very first learned start is already significantly reduced, almost by halfway. Now, because this compressor has no reversing valve or has no means by which to equalize the refrigerant pressures, we're going to let it rest for a couple minutes before we do another start. As we step through the learning starts, I would like to point out a few additional benefits from EasyStart's advanced design. First, for those of you who use the very popular Honda EU2000i generator, EasyStart allows you to run your generator with its Eco Mode switch turned on, which gains you much better fuel economy. Since the air conditioner's fan draws a few amps of current when the control turns on, EasyStart's 5-second delay allows the generator to complete its transition to high RPM mode before the actual starting ramp begins. Second, even after the start is completed, EasyStart continues to monitor the compressor's voltage, current, and rotation. Power brownouts, which are not at all uncommon on campgrounds, marinas, or when using generators, can cause the compressor to stall. And after power comes back on, immediately attempting to restart the compressor will not work because the high refrigerant pressures built up inside the system have not had time to equalize. EasyStart detects these brownouts, shuts down the compressor, and waits 5 minutes before automatically restarting. Lastly, as the EasyStart conducts its learning starts, the currents measured will vary slightly as it optimizes several internal parameters. Once completed, EasyStart stores the optimized parameters and uses them for the life of your system. If you replace your air conditioner and you want to move your EasyStart over to your new system, you can reinitiate the learning process by temporarily moving a jumper connection inside the EasyStart. For more information on all of this, please refer to the installation manual at the link shown in the description box below this video. Okay, we're ready to do the 6th start. The one-time learning process of the EasyStart has been completed. So now we're going to see what it shows for its final start profile, and we're going to see how well it does. There we go. EasyStart settled on a 17.3 amp start current, down from 41.1 or change, which corresponds to about a 70% reduction from the 54 amp lock rotor and about 60% down from the factory configured start, which is in the 41 range. That's going to work with your generator or your inverter or your weak short cord. So testing is done. Let's go ahead and finish this job by installing the EasyStart inside the electric box. All right, we're done. And the tent's up and it's cool inside. Wonderful thing. EasyStart. This model that we installed is the Model 364. It's good for an air conditioner up to 36,000 BTUs or 3 tons. This model is the Model 368. This big boy is meant for air conditioners 4 to 6 tons. And by the way, for all of our international customers out there, these EasyStarts work equally and without any changes on 115 60 Hertz, 230 60 Hertz, 220 to 240 50 Hertz. No issues. These are designed to work with both. And in fact, they optimize themselves differently depending on the line frequency, so that if you did in fact have a dual frequency compressor, EasyStart remembers what it learned when it was plugged into 60 Hertz and remembers what it learned when it was plugged into 50 Hertz, so we can go back and forth freely. And speaking of which, after we finished the learning process in the video with the 5 starts, after the learning is done, you can go back and forth between utility, generator, inverter, lousy short cord, whatever it is, and EasyStart takes care of adapting under all those conditions. So that's the beauty of EasyStart. It's going to take care of you no matter what your power source happens to be. So once again, big thanks for everybody who helped us out on this. Margaret and Brenda, and big ups to the Winds on their video and their adventures. They've got EasyStart aboard their boat now, and hopefully all will be well from them going forward. Thanks for watching, and don't forget to visit us at www.microair.net and order your EasyStart today. Thank you.